Welcome to June at Empirical's SDA Learning Center. In the last video, I demonstrated how to use smart tilings from the SDS Toolkit to transform a regular AutoCAD drawing into a hybrid schematic wiring diagram for AutoCAD Electrical. The promise of AutoCAD Electrical is speed, automation, and accuracy, but sometimes having to draw intelligent wires instead of lines, create wire sequences, and add a bunch of necessary but invisible attribute data to symbols erodes much of the gains in speed you were hoping to achieve. This is where AutoCAD Electrical circuits can give you a boost. In this video, I'm going to show you a very powerful tool in the SDS Toolkit that helps speed up inserting schematic material into schematic drawings with just a few clicks. The tool I'm talking about is the SDS Add Circuit Tool. In this AC drawing, I've already inserted the CT tap chart for my first breaker, so now I'll continue to insert the breaker components. Instead of inserting symbols one at a time, I'm going to use circuits. Under User Circuits, AC, I have a variety of 1/4 inch and 1/2 inch spacing options for grounded and ungrounded bushing CTs. Those come with cables or without cables, and also come with full bushing CT circuits that have cables and control panel equipment. I'll start with a blank 3-phase breaker circuit template, turn on my grid snap, and go about placing the circuit. It's good right there. Now I'll return to the icon menu and select User Circuits again and start placing some bushing CT circuits for this breaker. Under AC, I'll go with a 1/2 inch spacing option. I'll make this first bushing CT a shorted and grounded CT. Keep my options checked. And then just find a position on the bus and drop it in. Now that I've inserted that, I'll make some adjustments here just to clear up some space for the remaining CTs. And then return to the icon menu, AC, and under the 1/2 inch rung spacing, I'll go ahead and select a CT with cables as well as control panel equipment with the phasing ABC. The A phase will be on the 1-2 bushing, the B phase on the 3-4 bushing, and the C phase on the 5-6 bushings. Next, I'll insert an ungrounded set of bushing CTs. If I was to edit these circuits, I would simply open up the data editor in the SDS Toolkit and make adjustments there to the various wildcards as I'm placing. But for the sake of viewing time, I won't be editing or updating any of these symbols, just placing them. Now that I've placed that, I'll use the SDS Add Circuit command to build out and make changes to the schematic. We'll draw that out first and go ahead and just bring that out a little bit to create some space between the jumpers and the location box. So under the SDS schematic tab, there it is. I'll select Add Circuit and select the yard cabinet terminal on the Z winding CT. This brings up a list of options for specific phasing, as well as different cable spacing, whether it's 1/2 inch to 1/2 inch or 1/4 inch to 1/2 inch spacing. I'll go ahead and select ABC, 0.5 inch spacing on one side and then the 0.5 inch spacing on the other. And this just gives me a bare cable. The SDS Add Circuit command also allows me to match the tag of the symbol that I'm connecting to during this, which is a new feature that comes in handy for separating. Then I'll go ahead and return to the icon menu, and I'll just select the relaying equipment circuit and snap it in right there on that cable. Then I'll go over to the Schematic Edit Components tab, and under Edit Wires, Wire Numbers, I'll select the stretch wire and just stretch that cable conductor to the connection point of the schematic terminal. Now I'll demonstrate a change in phasing that affects the cabling. I could go about trimming and redrawing each individual conductor to the corresponding inputs, or I can delete them and use Add Circuit. So I'll delete the cables. Go ahead and just freshen up. And then hit Trim Wire. Just do a fence around these wires and trim them up. Once I go to the SDS Schematic tab and click Add Circuit, say I want to change this phasing to BCA phasing. I'll search down the list for the BCA phasing cables and go ahead and select the 1/2 inch spacing to 1/2 inch spacing cable and snap it right in. And then repeat the process one more time. Because we have standard grid spacing, it's very easy just to snap these cables in and exchange them and get a wire sequence that goes from the hard cabinet terminal to the control panel terminal. Search the list for the same exact cable, snap it in, and I'll go ahead and just select the defaults for that terminal. And you can see in this instance, they're already connected. There's already a wire sequence. And you can see there that in my Edit Wire Sequence dialog box is telling me that those are all connected. So when I go to annotate those cables on my connection and wiring diagrams, they're already seeing each other, and it only took a couple of clicks to get that to come in. I can also use the SDS Add Circuit Tool as originally programmed to just insert unintelligent blocks as well. Before I do that, I'll go ahead and insert a full CT circuit with all of the relay components to it. So I'll look for the phasing and for the full breaker version of the CT. There we go. Click OK and snap that in. As you can see, the circuits can be as simple or as complex as you want, depending on how you want to originally place them and maybe how you want to use these circuit tools and circuits for editing purposes. I can see there that I have wire sequences between those two. Yes. So now I'll go and add an unintelligent block to my circuit breaker. If I select Add Circuit and select the breaker, I get a full complement of door and operator mechanism orientations to pick from. I'll select the left side door block and click OK to insert the breaker cabinet door on the left side. SDS Add Circuit looks into the panel symbol library folder for the circuit files. This is probably due to the fact that it was originally programmed for wiring diagram symbols. To break down the file names based on the example circuits I previously inserted, the prefix add is for the SDS Add Circuit command to find the circuits. In the parentheses is a user-defined description. In this case, we use BCA to represent a phasing configuration. 50/50 indicates a 1/2 inch spacing on each end. Cable indicates that it's only the cable that's going to be inserted, and up or down indicate the final cable bubble position. The tilde symbol that follows separates that user description from the target symbol file's name. For more information on the file naming convention, see the SDS help file under the Add Circuit command. If I open up an example to explain the relationship between the circuit insertion point and the target symbol used in Add Circuit, the insertion point for the circuit is offset from the drawing origin point by the same distance as the associated symbol's insertion point. So you can see the terminal's connection point attribute is going to line up with the cable, and that's how much you have to offset the distances for the circuits so they snap in place. Because this happens, AutoCAD Electrical can see the connection in the Project Scratch database after you use the Add Circuit tool. I can quickly add schematic cable fan-ins using the SDS Add Circuit tool as well. I'll select what eventually will be the Z-winding bushing CTs and delete all symbols and wires. After that's processed, I'll delete the wires using delete, and then I'll invoke the Add Circuit command again. Select the yard cabinet terminal and open my dialog box. You can see just how many options that you can add using this tool: full circuits, cables, and even simple jumpers. Using a standard grid spacing is a key element to making this tool flexible enough for different applications and different standards. We have schematic jumpers for wire spacing from 2 inches all the way down to 1/4 inch. To find the fan-ins, I'll simply select the Show All box and show both the T1 wire change terminals and the T0 pass-through terminals for my schematic terminals. Once I find the correct cable, I can simply snap it in. Once I give the cable bubble an actual name, I can simply run the SDS update sig code command to update the source or destination signal arrows to match the cable tag. I can quickly add the jumpers on the neutral side of the CT by selecting Add Circuit, scrolling down to the correct spacing of the jumpers, which is the 0.25 or 0.25, and go ahead and just select the terminals and make sure I'm selecting the X1 or right side of the schematic terminal and snap that in. This demonstration was just an example of how powerful circuits can be for speeding up design, especially when designing from scratch. There's a strong tendency, in my personal experience, to start immediately converting AutoCAD drawings into AutoCAD electrical diagrams as soon as you're done building the symbol library. Taking the time to assemble common circuits during your library creation will not only save time on converting to AutoCAD Electrical, but it will also save you time when designing with AutoCAD Electrical every single day. The key thing to remember is that when using circuits, use a standardized grid spacing throughout the common drawing types like 3-line schematics or DC schematics. This makes the circuits flexible enough to use in any design for any piece of equipment that you might have. To add the additional power and flexibility of the SDS Add Circuit command, just follow a few simple rules for the file naming convention and insertion points, and you will get closer to achieving greater design accuracy, automation, as well as speed. Thanks for stopping in again. See you in July with more AutoCAD Electrical content here at the Empirical SDA Learning Center.